As we get into radicals, we need to be able to recognize perfect squares and perfect cubes and things like that to be able to simplify radicals. So first we're going to look at or make ourselves a list of numbers that are perfect squares. All right, so the first perfect square is 1, and this is a square root symbol. When you take the square root of 1, it's asking you what number to the second power would give you 1, and that would be 1 because 1 times 1 is 1. The next perfect square is 4. What number to the second power or what number squared would give you 4? That is 2. The next perfect square is 9, and its square root is 3 because 3 squared gives you 9. The next one is 16, and we'll keep going. The next one is 25. 5 squared is 25. Then 36. Then 49. 64. 81. And 100. 10 squared is 100. I'm going to go up to 12. 121. The square root of 121 is 11 because 11 times 11 is 121. And the square root of 144 is 12. Now obviously they keep going, but we're going to stop right there. Typically, if you know these, you should be able to simplify any radical that I give you. Now, we can also have variable terms that are perfect squares. X squared is a perfect square. Now, I'm going to use the variable x, but this could be any variable. It could be a squared, y squared, m squared. It doesn't matter. The square root of x squared is going to be x because x times x would give you x squared. All right, and in fact, any even power of x is going to be a perfect square. So x to the fourth is the next perfect square, and its square root is x squared because x squared times x squared gives you x to the fourth. The next one would be x to the sixth, and its square root would be x cubed because x cubed times x cubed gives you x to the sixth. Remember, with exponents, when we're multiplying, we add the exponents. So x cubed times x cubed would be 3 plus 3 to make that 6. The next one would be x to the eighth. And then, of course, like I said before, that keeps going. We're not going to list them all. But any even power of a variable will be a perfect square. All right, now let's talk about perfect cubes. All right, when you cube something, you're raising it to the third power. And when you take the cube root of something, you're asking what number cubed would give you that number. So the first perfect cube is 1. So that's the first number we can take the cube root of and get a nice whole number answer. All right, what number to the third power would give you 1? Well, that would be 1. 1 times 1 times 1 is 1. The next perfect cube is 8. And the cube root of 8 is 2 because 2 times 2 times 2 is 8. The next perfect cube is 27 because 3 times 3 times 3 is 27. These start to get big really fast. The next one is 64. 4 times 4 times 4 is 64. And the next one is 125. 5 times 5 times 5 is 125. Now, like I said, those will get big really quick. So we're going to stop at 5. Now, you can also have variable terms that are perfect cubes. Again, I'm going to use the variable x, but this could be any letter. The first perfect cube is x cubed because x times x times x gives you x cubed. So when you take the cube root of x cubed, notice how the cube and the cube root kind of cancel each other out. Okay, so if you have something cubed and then you take the cube root of it, the answer is just going to be whatever this base was, so x. All right, the next variable term that's a perfect cube would be x to the 6th. Now what term cubed will give us x to the 6th? That's going to be x squared. X squared times x squared times x squared is x to the 6th. Now notice here, 6 divided by 3 is 2. So that's a way to look at it as well. The next perfect cube variable term is going to be x to the 9th. All right, and the cube root of x to the 9th is x cubed. If you think about it, x cubed times x cubed times x cubed. If you add your exponents, 3 plus 3 plus 3 is 9. Also, 9 divided by 3 is 3. All right, we'll do one more so you can see the pattern. The cube root of x to the 12th would be x to the 4th. X to the 4th times x to the 4th times x to the 4th. You would add 4 plus 4 plus 4, and that would give you 12. Also notice 12 divided by 3 is 4. Now, the pattern here is that any variable raised to a multiple of 3 will be a perfect cube. So the next one would be x to the 15th, and then x to the 18th, and so on. All right, we can also look at numbers that we can take the 4th root of. These don't have a special name like squares or cubes, but we can take the 4th root of some numbers. The first one is 1. The 4th root of 1 is just 1. Now the 4th root just means what number raised to the 4th power would give you this number. So 1 to the 4th power is 1. And if you think the cubes got big fast, wait till you see these. The 4th root of 16 is going to be 2. 2 times 2 times 2 times 2 will give you 16. 4 twos. 2 times 2 times 2 times 2. So the 4th root of 16 is 2. And then the next one is 81. And that's going to be 3. 3 times 3 times 3 times 3. Okay. If you look out here, we got 3 to the 4th power. That would be 9 and 9, and 9 times 9 is 81. So that's why the 4th root of 81 is 3. Now we're going to stop there because, like I said, those get big really fast. But let's go on to our variables that we can take the 4th root of. The first one would be x to the 4th power. The 4th root of x to the 4th would be x, because x times x times x times x is x to the 4th. Again, 4 divided by 4 is 1. Just like over here, 3 divided by 3 is 1. 6 divided by 3 is 2. All right, the next one we can take the 4th root of is x to the 8th, and that's going to be x squared. Again, just to show you out here, what we're saying is if we raise x squared to the 4th power, or do it 4 times, it's going to give us x to the 8th. And you remember, when you're multiplying, you add your exponents. So 2 plus 2 plus 2 plus 2 is 8. That's why this answer is x squared. But also notice you can do this little shortcut. 8 divided by 4 is 2. So the next one that we can take the 4th root of would be x to the 12th. And that would be x cubed. 12 divided by 4 is 3. And then those keep going. And hopefully you see that the pattern is that we can take the 4th root of any variable raised to a power, not a power, raised to a multiple of 4. Sorry. All right, now we're going to just add a couple 5th roots, not many, because they really get big fast. The 5th root of 1 is 1. That says 1 to the 5th power gives us 1. The next one would be the 5th root of 32, which is 2. So let me just show you out here. That means 2 to the 5th power is 32. So if you multiply that out, you would get 32. Okay, that'd be 4, 4, so 16 times 2 is 32. All right, that's how we got 2 right there. And then the next one, look how big this jumps. 243. The fifth root of 243 is 3. Okay, well we're going to stop there. So those are things you can take the fifth root of. And if you wanted to look at variables, you can see this pattern. We can take the cube root of any variable raised to a multiple of 3. We can take the fourth root of any variable raised to a multiple of 4. So I would presume then that we can take the fifth root of any variable raised to a multiple of 5. So like the fifth root of x to the fifth would be x. The next one would be the fifth root of x to the 10th would be x squared. Again, 10 divided by 5 is 2. 5 divided by 5 is 1. And then we'll squeeze one more down here. The fifth root of x to the 15th would be x cubed. Okay.